Hey, what's up, everybody? Today is January 18th, another day of Leetcode. Let's go ahead and warm up our fingers a little bit and get to the actual problem. Okay, so just a heads up, I have been given a little bit of advice about this current problem before I actually had done it because I was in other people's streams. But I'm going to go ahead and show you the problem now and we'll see what we can do. Trapping rainwater 2, this is a hard. I honestly don't know if I would have been able to solve this without some guidance on it a little bit. And so the idea is that we basically want to have we're basically doing kind of like a breadth first search, but with a priority queue in the sense that we want the smallest values from the outward in, and every time, or we're basically kind of like checking all the edges that we haven't seen or whatever. And if the value is smaller, we can level out the kind of like the field or the, because the water can never go past the block size. So basically, you can say it's at this level, and then the rest is are basically our water, right? I mean that's the general idea. Anyway, I'm just gonna try and see if I can code it the way I'm picturing my head before I stop thinking about it. But let's go ahead and read the problem. Given an m by n integer matrix height map representing the height of each unit cell in a 2D elevation map, return the volume of water it can trap after raining. So the idea is that you have these blocks, and if it can contain water, it has water, and if it's on the edge, it doesn't, because it basically would spill out, right? So you have, for instance, these blocks, it can't go any higher than these kind of blocks. So we're going to go ahead and try and create our priority queue. And I always get them mixed up. I'm not sure if I need the greater tag or not. So what I'm going to do, just to test, is I forget. If this prints 3, I'm good. Okay, so this printed 4, which means this needs to be backwards. Uh, like this. So now I should get 3 on the top. 3. Okay. So now we want to do the entire first row, the entire last row, and then in between, right? However, this is a vector, which means it's based on row and calls. So we need to change this to pairs. Wait, hold on. We might need to change this to a tuple. Because the height map has 3 specific data types, right? Row, column, and the height, right? So we need a tuple. Okay, and it's going to be the same thing for this. I can just do this. Now, I'm not always a big fan of tuples because of the weird syntax, but we're going to just work with it. Now, as far as the first values are concerned, we're going to go through the rows and columns and then use the height map in order to store the data. And the height, because we're going to be using the min height to determine which ones we're going to go to next, right? So we're going to go okay, so oh no, let's go through the columns first. Yeah. So we're going to go through each column, and we're going to stay on row 0, and then each column on row at end. So we're going to go pq.push. It's going to be a tuple, so we're going to create a curly brace thing with the 3 values, elements. And then we're going to put the height map, and this is going to be at 0C, and then we're going to be 0 and C, right? So we have our height, our row, and our column. And then we're going to do this same thing for the lowest row. So it's going to be the same thing, basically. Height map, and then the bottom row, which is going to be height map dot size -1, the and then height map dot size -1 and C, right? And this will give us the bottom. Okay, so now we have all the top columns, all the bottom columns. Now we need the in-between for the rows on the edges, which we can do here. Where instead of this, we're going to start with 1. And then we're going to go to the end -1. Okay. And this basically gives us the values in the center columns instead of everything except for 0 and the end for the because we already got 0 0 in the end. So then we're going to go to pq.push, and this time we're going to be using R. Oh no, I'm sorry. We first need the height map element, which is going to be starting at R and then column 0. And then it's going to be the same here. Push map R, and then it's going to be the end of the columns. So it's going to be height map, and then we're going to say 0 size -1. All right, and then we're going to put this in the same thing, row, and height map 0.size -1. And then this is going to take care of the rows in between automatically for the for loop, because we're just going to the edges. Now, once we got this, we kind of want to treat it like a BFS. So we're going to go while it's not empty. We are going to, so because we are doing, it's not a level order traversal, so we don't need the size for every level. We're going to be picking them off from the top, each one. So we can go ahead and break down whatever's on top. And we're going to go ahead and say height, row, and call. right? So now, oh, we also need to first have, I like to put all my data in one spot. So I'm going to say int result. We might need directions too, because we want to check every direction. So vector int vectors equals -1 0 1 0 0 -1 0 1. Okay. So to check its neighbors, we're just gonna go for auto ders, and then we're gonna go int in R equals dir 0 plus R equals dir 1 plus C. Okay, and this is basically the neighbor of the one that we're looking at. And we want to compare the neighbor's value and the value that we're on. But we also need... Okay, so if we're doing this way too, we're also going to need some kind of like way of detecting all the stuff that's already in the priority queue. Because if it's in the priority queue, we don't want to reinsert something that's already in the priority queue, right? So I'm thinking a scene vector might work. And then we're just going to go... so we're going to tell its dimensions. And we're just going to say that it wasn't visited, and we're going to assume that 0 means false. So we're going to fill it with the 2D vector with 0. But then we need to tell it for everything that we've seen, we need to insert it into scene. So we're going to go scene 0 C and scene size -1 C1. Same thing with this. Scene R0. Last but not least, scene R height size -1. Okay, so this, everything we put in as the edges are all going to be considered scene, so we shouldn't backtrack into scene, right? Okay, so we're in our thing here. If nr is less 0, or nr is greater than or equal to height map dot size. So basically, if it goes out of bounds, we're going to continue because we can't use it. Same thing with the columns. Okay. Now, if the new value is already in the thing, we don't need to touch it. So if scene. Now, the reason I'm doing it this way is because when you say scene in RNC, if it is 1, it is true. And you can say if true, do something. So we're going to say if true, continue. Now, if it's not true, we're going to go in R, in C, and make it true. So we only visit it once. Now, once we've done this, we want to say if the new value, so height map in R in C, if the new value that we're going to is less than the current one that we're on, so I can just say height, I think. Yeah, I have it right here. So if it's less than height, it basically means that actually we're gonna have to push it to the thing anyway, even if it's not adjusted to the height. So, but if it is less than, then we want to set the new value. Or no, it's first off, we need the difference for our result. So this is basically where the point is. If the edge of the wall is, if it's less than, right, then we need the amount of water that we're going to take from that wall, because it is the smallest value that's possible, that's holding it in place, which means it's going to be level. So we're going to say result plus equals, and it's the difference between the height and the height map. So the height is going to be greater. So height minus height map in our NC. Okay, that should give me the new, or that should give me all the water that can be contained in that position, because it's at the lowest level. And then we want to set this new position, so basically acting like the water is now a wall, so that we can kind of cover inwards. And we're going to say the height map of, or the new height map should be the height of the position that we're on. And then we're going to go ahead and, because it wasn't seen before, we're going to go ahead and push this value. And the new value is going to be the same height as the value we just before. And we're going to say in our NC. Or no, I'm sorry. Yeah, because if the value is greater, we should be putting it in there like that. Okay, so if this is done right, I think this should basically be how to do it. Because it's going to go through and check everything, and then every time it's lower, it's going to do the thing. So run. What'd I mess up on? Uh-oh. Okay. Why is it TLing? If continue. Oh, I forgot to pop each element off the priority queue. There we go. Oh, that scared me. I was like, oh man, the logic makes so much sense. And then, yeah, okay. And this is a basic. It kind of reminds me of something else I've done before, but not so much with the priority queue, but with the kind of like island problems a little bit. I guess they share some similarities. Okay, let's just check to see if this is correct. Okay. Yeah. That's a pretty cool problem. I'm very thankful for the advice I got about the priority queue and going inside out, or going outside in. That those two things basically gave me the solution that was this. Okay, well, if you liked my solution, well, partly my solution, we did learn a little bit today, which is fundamentally what I'm going for anyway. And if you have any questions, leave them down in the comment section. I wouldn't mind answering anything you have. And thank you for joining me. I hope you have a wonderful night or evening or whatever. Peace.